In this video, we will be looking at more application problems, but in these different scenarios, we're going to be creating diagrams that involve multiple triangles. So once we take the words and create our diagram, after that, we are going back to our knowledge skills of solving for missing sides or angles when we have multiple triangles attached to one another. So let's start with our first one. Two towers face each other, separated by a distance of 20 meters. As seen from the rooftop of the first tower, the angle of depression of the second tower's base is 60 degrees, and the angle of elevation to the top of the second tower is 30 degrees. What is the height of each tower? The fact that standing on top of one building you have an angle of elevation and angle of depression means that you have one tower that is taller than the other. So to start off, I will draw a shorter tower, the distance between them, and then a taller tower. So I know the distance between my two buildings is 20 meters. Then, because you're given that angle of depression and elevation, you know you must be standing on top of the shorter tower. That way you can look up and look down to the top of the other building and the bottom of the other building. So because we know that our regular sight line is horizontal, I'm going to draw a horizontal line. And now it says that the angle of depression to the second tower's base is 60 degrees. So when I look down to the base of the second tower, the angle between my regular sight line, which is the horizontal line, and looking down is 60 degrees. Then the angle of elevation, so if I look up to the second tower, is 30 degrees. What is the height of each tower? We also know that this 20 meters is also this side length right here. So we need to solve for the height of each building. So if I label this X as the height of the smaller building, it will be the same as this side length here. And then my taller building is this entire length. So if I can solve for X in one of the right triangles, and then let's label this Y in the second right triangle, I can add them up to get the height of the larger tower as well. So in this scenario, we have created two right triangles. So we can use SOHCAHTOA to solve for X in the bottom triangle and Y in the top triangle, and then state our two different heights. So let's start with the bottom triangle to solve for X. So X is my opposite, 20 is adjacent, and my blank side is the hypotenuse. So because we're looking for opposite and we have adjacent, we will be using tan. And it's going to be tan of 60 equals opposite over adjacent. Let's put the tan 60 over 1. And now we can cross multiply so that we end up multiplying 20 and tan 60. This will give us approximately 34.6 meters. So X is also the height of the smaller building. So there's one height ready to go. Now we can look at our top triangle here where we're looking for Y, but now we're using 30 degrees as our reference. So Y is opposite, 20 is still adjacent, and the hypotenuse is the blank side. So now once again, opposite and adjacent is tan. So we're going to have tan of 30 degrees equals opposite over adjacent. And again, we cross multiply here. And when we put that into our calculator, we will get approximately 11.5 meters. Now this 11.5 meters is not the height of the second tower. That is just the top little portion. So we have to add these two lengths to get the taller building's height. So 34.6 plus 11.5 is 46.1 meters. So that's the second tower. And now we can write our therefore statement. Therefore, the buildings are 34.6 meters and 46.1 meters tall. And that's it. So make sure for this type of scenario, when you have your two towers and you're given two different angles, make sure your angles start from the smaller building. That way you can look up and down. All right, let's go to our next one. Find the area of a triangular garden that has a base length of 8 meters and whose two base angles are 44 degrees and 65 degrees. Okay, so area should make us think of area equals base times height divided by 2. And we're already given the base. So let's start off by drawing a triangle where the base is 8 meters and we're told that our two base angles are 44 and 65 degrees. And the minute I have those two angles, I am going to go ahead and do 180, subtract 44, subtract 65 to get this top angle as well in case I need it. So that's going to be 71 degrees. Now, because my goal is to find the area, I know I need to find the height of this triangle. So I'll label that H. But I can't find that height right away because if we look at either one of our right triangles that I just created, we don't have a side length in either one because this 8 meters is the base of the oblique triangle. So I can't use that in the right triangles, which means I have to solve for this hypotenuse or this hypotenuse here. The choice is ultimately yours. So let's just say we're going to solve for this length here, and I'll label that as X. So first thing, we're going to look at this entire oblique triangle here. And I notice that I have a nice full pair between the 71 degrees and the 8 meters because that 71 is this entire angle. So these pair up nicely. And because I chose X as the side I want to look for, although it could have been the other hypotenuse as well, that will pair up nicely with the 65 degrees. So we can go ahead and use our sine law to solve for X. And once we have X, then I will have a side length in this right triangle, and I have my reference angle here, so I can do SOHCAHTOA to solve for the height, and then I can find my area easily. We've actually done one of these questions in our multi-triangle knowledge questions. So why don't you pause the video here, set up your sine law, solve for X, then go ahead and look at the right triangle to solve for the height, then find your area. Then come back to check your work with me. So for your sine law setup, you have 8 over sine 71 equals X over sine 65. You cross multiply, so X with sine 71, 8 with sine 65. Divide both sides by sine 71 to get rid of it on the left. And hopefully for X, you got 7.7 meters. And now that we have this, looking at just the right triangle, I have my reference angle, I'm looking for opposite, and I have the hypotenuse. So hopefully you chose the sine ratio. So sine 44 equals opposite over hypotenuse, and then cross multiplied. Now technically you could have done sine law in the right triangle, it just takes more time. So the height should be 5.3 meters. Now that we have our height and we know our base and we know the area of a triangle, we can go ahead and set that up. So base of 8 times height of 5.3, all divided by 2. And our area is approximately 21.2 meters square. And that's it for this one. So whenever you are trying to solve for the height of a triangle, you will have to solve for one of those hypotenuse lengths in either triangle so that you can then use SOHCAHTOA to solve for for your height. So you look at the big oblique triangle, then fixate on either one of the right triangles on the right or left of the height. All right, let's go to our next one. A flagpole stands on the top of a building. A person lying on the ground 20 meters away from the base of the building observes that the angles of elevation to the base and the top of the flagpole are 20 degrees and 24 degrees respectively. What is the height of the flagpole? All right, let's start with a diagram. So let's say that this here is my building and this is the flagpole. So we have to differentiate between the two. There's someone lying down on the ground 20 meters away from the building. And they look up to the flagpole, but they're looking up at the base of the flagpole and at the top of the flagpole. That's why we have two angles of elevations. So to the base, we have 20 degrees. So this smaller angle here is 20 degrees. And then this big angle, or slightly larger angle, is 24 degrees. So that will be from the ground all the way to looking up at the flagpole. And our goal is to solve for the height of the flagpole. Now, we can see that we have created two right triangles. We have this small one here that has a 20-degree reference angle, and we have the large one here with the 24-degree reference angle. If you want, you can break these up to see them a little more clearly. They both have a base of 20. Here's the reference angle of 20 degrees when you're looking at the base of the flagpole, and then 24 degrees here. Now, if I want to solve for that height that I've labeled as h, I can just solve for x and solve for y and subtract them. So if I find that length in the big triangle and I find the length in the smaller triangle and subtract them, the difference will be the height of the flagpole. So here we are just relying on our SOHCAHTOA knowledge. And in both of these scenarios, x and y are opposite. The 20 is adjacent to both of the reference angles, and the hypotenuse sides are both blank. So if we think about opposite and adjacent, that is tan once again. So I want you to pause the video here, set up your two tan ratios to solve for x and y, and then go ahead and find the height of the flagpole. So for x, we are in the big triangle. So we have tan 24 equals opposite over adjacent of 20. And then you can cross multiply. So 20 times tan 24. And you get approximately 8.9 meters. Then we can do the same thing, but using 20 as our reference. So now opposite 20 is y, and adjacent is still 20. So now y is equal to 20 times tan of 20 degrees. And hopefully you got 7.3 meters for that. And now, if we can just subtract the two, the difference will give us the flagpole. And that is 1.6 meters. And because it is a word problem, therefore the flagpole is 1.6 meters tall. And that's it. So the diagram is slightly different, and it might be trickier to set it up at the beginning as you get used to these kinds of word problems. But the solving, you're still using your same knowledge of SOHCAHTOA or sine law or cosine law. And now the final question. Rosie is talking to her friend who is up on a balcony. Rosie sees her friend at an angle of elevation of 42 degrees. She walks 3 meters closer and her angle of elevation changes to 64 degrees. How high up is her friend? So let's say her friend is up here. And Rosie's on the ground here. So R for Rosie, F for friend. From her current location, when she looks up at her friend, her angle of elevation is 42 degrees. But then she walks 3 meters closer, and now when she looks up, her angle of elevation is 64 degrees. And our goal is to see how high up her friend is. So I will label that as H because that is our ultimate goal. Now, I know when I solve for H, I'm going to be either in this right triangle or the big right triangle. I personally like to look at the smaller one because it's easier for me to see. But if I look at this right triangle, I don't have any side lengths. I have my reference angle, which is great, but I don't have adjacent and I don't have the hypotenuse. I can't find the adjacent because it's not shared with the oblique triangle, but the hypotenuse is. So the first thing I'm going to do is focus on this oblique triangle, and I'm going to label this side as X, and that is the first thing I'm going to find. Now, X is opposite to the 42 degrees, so that would be a pair, and I don't have any other angles, but I can solve for them. So I have an angle that is supplementary to 64, so if I do 180, subtract 64, I get 116 degrees. Then I can find the third missing angle by doing 180, subtract 116, subtract 42, and you get 22 degrees. So this 22 degrees is opposite the 3 meters, so that's a full pair there. And then the 42 matches up with the X, so this should be our sine law. So this type of question we have done before in the multi-triangle setup with just our knowledge, but now it's tied up with the word problem. So we took the words, created the triangle, now we're back to this similar scenario. So I want you to pause the video here, do your sine law to solve for X, then use SOHCAHTOA and look at that smaller right triangle to solve for H. Then come back to the video to check your work. So for your sine law, you should have 3 over sine 22 for your full pair equals X over sine 42. Cross multiply and divide out that sine 22 from both sides because we're solving for a side length. And hopefully for X you got 5.4 meters. And now, I'll just label that in our diagram. But now across from the 64 is opposite, that's our height. Adjacent is the base that we don't have, and X is the hypotenuse. So opposite and hypotenuse should make you think of sine. So hopefully you have sine 64 equals your height over your hypotenuse, which we just found. And then another quick cross multiplying to do 5.4 times sine 64. And your height should be approximately 4.9 meters. So that means Rosie's friend is 4.9 meters high. Therefore, and that's it. So the more practice you do, the more familiar you'll get with the different setups and just the communication of different triangles.